The new section today is 6.4. So 6.4, using tables to explore ratios and rates. So using tables, by that they mean data tables, to explore ratios. So two numbers like 1 to 3 where the units are the same, and rates. Should be like a 1 to 3 where the units are different, so like 1 mile every 3 minutes or something like that if you're biking quite fast. Want to do really just kind of 2 examples, and then we're pretty much done with this. And it kind of goes back to what you were doing already yesterday in the homework in a couple of the questions. It's just kind of set in a different format. So I'm going to say example 1, fill in the table with ratios equivalent to 2/3. Equivalent is the math word. Normal people, when they say equivalent, they think equal. So we're really just trying to say we want to make a data table with a whole bunch of equal ratios. And you remember the questions in the homework yesterday where you're doing that? You had to come up with like 3 different ratios that were all the same, or 3 ways to write a ratio, something like that. And I'm going to just kind of make a data table. And
How many boxes?
I have no idea. Let me count. So I have 6 in my notes, so maybe I'll just do that there. And in hindsight, I'm probably going to end up like really trying to squeeze the numbers in, so mine are probably going to be way too small. But and I'm going to have my first one just be 2/3. I'd like a pretty and a small number.
3.
3 works for me. If we wanted to get a ratio that's equal to this, we could do 2 times 3, which gives us 6, and 3 times 3 gives us 9. So 2/3, kind of this first column here, 2/3 that ratio is going to be equivalent or equal to the second one, the 6/9. Maybe another number? 2 works for me. Do we want to do let's maybe do the 6 times 2. So I'm going to kind of do like a times 2 right there and a times 2 right there. But erase my little times 2. So 6 times 2 is 12. 19 times 2? 18. And if you wanted to, you could even go back to that original number, and to get this one, I'm going to take my starting ratio, oopsie, go to there, and I'm going to multiply both of those buggers by 2. So 2 times 2 is 4, and 3 times 2 is 6. I don't know. What's another number? Anyone? 4. Should we do the 4 times 4? 4 times 4 is?
16.
And 6 times 4 is?
24.
24. So there's all kinds of different options you could get for filling that thing in. Yes? This last number, kind of as a segue into my last example, I'm going to take and I'm going to put 100 up here in the top. So sometimes it's a choose your own adventure, pick a number, get an equal ratio. Sometimes they're going to give you one of the 2 numbers, say, all right, if 100 is in the numerator, what has to be in the denominator? Dun, dun, dun. If I lost you, maybe think of this. Look at all those other numerators. So all of these, the 2, 6, 12, 4, and 16. Which one of those can you change into 100 easily? Which one could you multiply by something to get 100? Go for it, Zach. 2. So 2 times what gives me 100? 50. So do you agree if we multiply the 2 by 50, I get 100? So what do I have to do to get that denominator, that bottom number? Yeah, I have to do the 3 times 50. Just like before, we were always multiplying by like 2 or 3 or 4 or something like that. 3 times 50 is 150. So that last one would be 150. Seem to make sense? And that's really just what my second example is. And this I thought was really pretty cool, so I stole it from the book. So my example 2, they say mammals, which include us, you breathe about 1 time for every 4 heartbeats. So 1 breath per 4 heartbeats. And I just thought that was interesting. So now if I'm going to take and make my data table with that, I'm just going to have like 5 sections this time, but I'm going to try to make them bigger so I'm not squeezing numbers in there. So 1, 2, 3, 4, 5. And apparently I didn't need to make it quite that large. But so if I have 5 like that, Yeah. The word per, so when you say 1 breath per 4 heartbeats, per means what math operation? Division. Nice. So you could write that first one as just being kind of like a 1 to 4 ratio, or a 1 divided by 4. So I wouldn't write it over here, but we're kind of saying like our first ratio is 1 to 4. That's kind of the base one. Then you could go through and you could pick different animals. So a grizzly bear, I think it was like 10 breaths a minute. So if we say for a grizzly bear then, if you have a 10 in the numerator, or in the top of the data table, what does the denominator have to be for the bear? 40. And as far as getting that, well, from here to here we multiply by 10. So then there to there we'd multiply by 10. Agreed? And then if we were to get rid of those. All right, and the next one they have is a human. Human resting heart rate is around 60. So we want to change the 4 to the 60 or the 40 to the 60. Who can see how to do one of those two? 40 to 60 is 1 and 1.5, right? Because half of 40 is 20. So what's 1.5 of 10? Well, 1 of 10 is 10. Half of 10 is 5, so 15. 10 plus 5 is 15. So humans should breathe about 15 times every minute. So you could kind of try to watch somebody or maybe see for yourself. But I know for me when I'm paying attention to my breathing, it changes it. So when you're doing a fast walk, somebody's maybe breathing, or their heart's maybe beating about 120 times a second. So then number of breaths would be, well, from 60 to 120 is multiplying by 2. So then 30. So we multiply up there by 2 also. And they give me a 30. And last one is a mouse. The mouse had 170. I probably should have labeled these at the beginning, but breaths. I don't know if you want to. I just think it's interesting. You probably don't need to, but it could help if you're trying to do like story problems to have them labeled. So a mouse is about 170 breaths every minute. So how many times does their heart beat every minute then? So you could try to take 30 into 170. Ooh, that's ugly. Probably the 10 or the 1. What's that? You're on the right track, but no. I guess actually there's a couple ways you could do it. Do you agree to go? You could do this. You could do from 10 to 170. That's right there is going to be times 17. So you could do 40 times 17. So times 17. To get that number. 40 times 17 isn't going to be the easiest thing to do in your head. Do you agree? Here's the other option. To get from the numerator to the denominator, do you agree I'm always multiplying by 4? So 1 to 4 is times 4. 10 to 40 is times 4. 15 to 60 is times 4. So I could do 170 times 4. So what he was saying is times 2 gets me 340. So we just need to double 340 again. So it should be 680. Very nice. So a mouse's little tiny heart beats supposedly 680 times a minute. Isn't that crazy? But that's it.